Hello there, and welcome to the Sleepy Science Channel. Tonight, we're going to travel somewhere very close, closer than any forest or ocean we've ever visited together. Tonight, we're going to wander gently through the quiet universe that lives inside you. The human brain, that soft, humming place where everything you've ever felt, dreamed, or wondered comes from. Where right now, even as you begin to feel sleepy, something extraordinary and gentle is happening. Don't worry. There are no complicated words here, no sharp edges to this story. Just soft light, easy ideas, and the kind of quiet, knowing that settles you deeper into warmth. Let's begin. Somewhere nestled inside your skull, protected completely, sitting in a kind of stillness that nothing can disturb, is your brain. It weighs about 3 pounds, roughly the same as a ripe cantaloupe or a small sleeping cat curled up tight. 3 pounds that hold every memory of autumn light you've ever loved, every song that made your chest feel full, every face that made you smile without knowing why. It is soft to the touch, your brain. Not hard or mechanical the way we sometimes imagine thinking to be. It is soft and gray-pink with folds and curves like a gentle landscape seen from very high above, hills and valleys, quiet ridges, small wandering rivers of tissue that carry your thoughts from one place to another, slow as water finding its way downhill. Those folds exist for a beautiful reason. If you were to take your brain's outer layer, a thin, delicate sheet called the cortex, and spread it completely flat, it would cover roughly 4 sheets of letter-sized paper. The folding is simply nature's way of fitting something very large into something small, like tucking a whole meadow into a paper envelope, and somehow, miraculously, the meadow still breathes. Your brain has about 86 billion nerve cells. That number is almost impossible to hold in your mind, which is a little funny when you think about it. If you tried to count each one, counting at a pace of 1 per second, day and night, without ever sleeping, it would take you almost 3,000 years. That's longer than from ancient Rome until right now, this quiet evening, as you breathe slowly and let your eyes grow heavy. These nerve cells are called neurons, and they are slender and branching like trees in winter, like those bare silver trees you see against a pale sky, with their fine arms reaching outward in every direction, fingertips almost touching neighboring branches. Each neuron reaches toward other neurons, and they communicate not through sound or light, but through tiny electrical sparks, the softest possible lightning, flickering constantly, even now, even as you rest. A single neuron can have up to 10,000 of these reaching connections. 10,000. Like a tree with 10,000 delicate branches, each one resting against another tree's branch. And there are 86 billion trees in this forest inside you. The number of possible connections in a human brain is greater than the number of atoms in the known universe, which means, in a very real sense, the space inside your head is larger than the space outside it. Isn't that a peaceful kind of thought? that you carry something infinite with you always, even when you sleep? Your brain is always on. Even now at this drowsy hour, with your breathing slowing and your body growing heavier, your brain is gently humming. It never fully stops, not even in the deepest sleep. It simply changes its rhythm, like a stream that slows in winter but never quite freezes through. The brain uses about 20% of all the energy your body produces, and yet it makes up only about 2% of your body weight. It is a small thing that asks for a great deal of warmth and fuel. In this way, it is a little like a candle, tiny, but casting light that fills a whole room. That energy it uses comes mostly from sugar, simple, quiet glucose, drifting through your blood and crossing gently into the brain, where it's welcomed, like a traveler returning home after a long walk. Your brain is always waiting for that warmth, always accepting it, always grateful. Your brain is divided into two halves, two hemispheres, like two cupped hands facing each other. They are connected by a thick bridge of fibers called the corpus callosum, roughly 200 million individual fibers bundled together like the softest possible rope. These two halves spend every moment of your life sending messages back and forth across that bridge, collaborating on absolutely everything you think, feel, or notice. The right side of your brain controls the left side of your body, and the left side controls the right. This crossing over happens deep in the brainstem, silently, the way streams cross under roads without anyone thinking about it. Your right hand moves because your left brain asked it to. In the crossing, there is a kind of poetry. If you've ever watched light move on water and felt something without being able to name it, that feeling came from the right side of your brain. If you've ever done a bit of arithmetic and felt satisfied at the clean answer, that was largely your left hemisphere, orderly and pleased with itself. Both are always working, always talking, always weaving your experience together, like two hands braiding something soft. The surface of the brain, that folded, gentle outer layer, is called the cerebral cortex. The word cortex simply means bark, like the bark of a tree. Isn't that lovely? Your outermost thinking layer shares its name with the quiet exterior of an oak or a birch standing calmly in the forest. This cortex is where most of what you think of as you lives. Your memories, your ability to plan ahead, your sense of humor, your appreciation for the sound of rain on a rooftop. It is only about 2 to 4 millimeters thick, thinner than your little fingernail, and yet it holds more than any library. At the back of your brain, nestled beneath the cerebral cortex like a small, separate country, is the cerebellum, a word that means little brain. It is wrinkled and rounded, and it manages your balance and your movement quietly and continuously, making tiny adjustments you'll never consciously notice. When you shift in your bed just now to find a more comfortable position, your cerebellum helped you do it smoothly and without fuss, like a good assistant who never asks for recognition. And then there is the brain stem, the oldest part, the deepest root. It connects your brain to your spinal cord and manages the things that must never stop. Your breathing, your heartbeat, your body's temperature. It does not need you to think about these things. It simply does them steadily, reliably, like the earth turning. Something you can trust completely, something that has never once let you down. Right now, your brain stem is breathing for you. You didn't decide to breathe just now. It was already done before the thought could form. That is the brainstem's gift, a kind of vigilance so deep and quiet it becomes indistinguishable from peace. Tucked inside your brain is a tiny structure called the thalamus, about the size of a walnut, sitting nearly at the center of everything. It acts as a relay station, receiving signals from your senses and directing them to the right places in the brain. Every sound you hear, every sensation on your skin, every flicker of light you notice, it passes through the thalamus first, like mail passing through a quiet, efficient post office before reaching the right door. Just below the thalamus, smaller still, is the hypothalamus, no bigger than a pea, and yet it manages your hunger, your thirst, your body temperature, your sleep. It is the hypothalamus that is gently urging you toward sleep right now, reading the light levels, listening to your slowing breath, sending the softest signals downward. It is time to rest. Everything is fine. You can let go now, and you can. You really can. There is a place in your brain called the hippocampus, named after a seahorse, because early scientists thought it resembled one, curling and graceful. There are two of them, one on each side, and they are where your memories are first formed. New experiences arrive here first, like visitors to a quiet inn, and the hippocampus helps decide what to keep, what to let go, and where to put what stays. While you sleep tonight, while this story trails off into warm silence, your hippocampus will do some of its most important work. It will sort through the day's experiences, sending the meaningful ones off to long-term storage in other parts of the cortex, filing them carefully in the dark, like a librarian who works only at night. If you find yourself enjoying this gentle journey tonight, you're warmly welcome to leave a little comment below, even just a word or two about how you're feeling. It genuinely makes the channel feel alive and warm, knowing you're here. And if you're settling in for the first time, there's a whole playlist of stories just like this one waiting for you whenever you need them. For now, just breathe. Let your body feel heavy and good. Let the warmth of your blanket be all the world there is. We're only just beginning. The brain, for all its complexity, is surprisingly humble in its appearance. If you were to hold one, as medical students sometimes do, you might be struck by how quiet it seems, how still. There is no buzzing or clicking, no visible light, just this soft, folded thing, dense and cool to the touch, that somehow produces the entire felt experience of being alive. Every color you've ever seen, every dream you've ever drifted through, every moment of recognizing someone you love from across a room, all of that, from this quiet, unassuming thing. The brain is about 75% water, which means your thoughts, in some sense, are mostly water. like rain, like rivers, like the light mist that hangs over a lake at early morning before the world has quite woken up. When you are well hydrated, your brain moves more easily through its tasks, the way a wooden boat moves more smoothly on a full river. When you're a little dehydrated, thinking can feel slightly slower, like that boat dragging gently on shallow ground. So, water is not just for your body, it is for your thoughts, for your dreaming. Every glass of water you drink reaches your brain eventually, joining that quiet, mostly liquid universe inside your skull. There is a system in your brain called the default mode network, a collection of regions that become most active when you are doing nothing in particular, when you are daydreaming, when you let your mind wander without a destination, the way you might walk slowly through a garden without meaning to go anywhere, just noticing things. For a long time, scientists thought these resting moments were wasted, that a wandering mind was an unproductive one. But it turns out the default mode network is doing something extraordinary. It is where you make sense of your own story, where you think about other people, imagine their feelings, plan your future, and quietly process the emotional texture of your days. The wandering mind is, in a way, the most thoughtful mind. Your brain produces its own electricity. Right now, neurons are firing in gentle patterns, creating tiny waves of electrical activity that move across your brain like slow tides. Scientists can measure these waves, and they've given them beautiful names: alpha waves, theta waves, delta waves. Each one has a different frequency, a different rhythm. Alpha waves are the ones you're likely producing right now as you relax and let your thoughts soften. They feel like a still lake, like a clearing in a forest where the light comes through in long golden bars. When you drift into deeper sleep, your brain will move into slower delta waves, the slowest of all, like the deep, barely perceptible pulse of the ocean floor. These are the waves of true rest, the waves of restoration. Your brain's neurons communicate using chemicals as well as electricity. These chemical messengers are called neurotransmitters, and they are extraordinarily delicate, tiny molecules that float across the small spaces between neurons like seeds drifting on a breeze. One neuron releases them and another receives them, and in that exchange, something happens. A thought forms, a feeling rises, a memory surfaces like a bubble from deep water. Serotonin is one of these messengers, gentle and familiar. It's associated with feelings of calm, of contentment, of things being quietly all right. It is sometimes called the well-being molecule, though it does far more than that simple name suggests. Serotonin helps regulate your sleep, your appetite, your sense of connection to the world around you. A warm bath, a kind word, an evening that ends peacefully. Each of these can coax a little more serotonin into the spaces between your neurons. Right now, drifting here in the quiet, you may be producing a little extra serotonin, which means this gentle story is, in a very small and real way, becoming part of your chemistry, becoming part of you. Dopamine is another neurotransmitter, one that moves through you when something feels rewarding, when something clicks into place, when a problem resolves, or a song reaches its most satisfying moment. Dopamine doesn't require grand events. It can be sparked by the smallest things. Finding a comfortable position after a long day, the first sip of something warm, the moment a story begins and you feel yourself relax into it. There is a molecule your brain releases during deep relaxation and sleep called GABA. And its job is essentially to quiet things down, to turn the volume lower, to say gently but clearly, we are safe, we can slow down, nothing urgent is required right now. GABA is like a hand placed softly on a shoulder, a reassurance without words. As you breathe slowly right now, as your body grows heavier and your eyelids feel that pleasant weight, GABA is increasing its presence in your brain, whispering its quiet message through millions of synapses. Rest is allowed. Rest is good. There is nothing that cannot wait until morning. Your brain has a dedicated system for handling emotion, a set of structures called the limbic system, nestled deep inside, older than your reasoning and language centers. At the heart of the limbic system is a small, almond-shaped cluster called the amygdala. It is involved in emotional responses, in noticing things that matter, in the instinctive recognition of faces and voices and situations. But the amygdala has a peaceful side too. It is equally involved in recognizing safety, in that full-body exhale that comes when you arrive home, when you hear a familiar voice, when you sink into a chair that knows the shape of you. The amygdala is always asking, quietly and constantly, are we okay? And right now, with your body settled and your breathing slow and the night soft around you, the answer your brain is receiving is yes. Yes, we are. Your prefrontal cortex, the region just behind your forehead, is one of the last parts of the brain to fully develop. It keeps growing and refining until your mid-20s, slowly and patiently, like a tree that takes decades to reach its full height. The prefrontal cortex is where judgment lives, where careful decisions are made, where you can pause before acting, consider consequences, imagine other perspectives. It is also, interestingly, where the ability to imagine the future lives. Your prefrontal cortex is what allows you to picture tomorrow morning, to imagine the light coming through the window, the warmth of a slow start, a cup of something good in your hands. This ability to mentally travel through time, forward and backward, is something human brains do with remarkable fluency, and it means that even in rest, even in the quiet before sleep, part of your brain is gently constructing possible futures, peaceful and unrushed. What future is it building for you right now in the soft darkness behind your eyes? Your brain is wrapped in 3 protective layers called meninges, like 3 gentle blankets, one inside the other. The outermost is thick and tough like a strong leaf. The middle layer is web-like and delicate, and between it and the innermost layer flows a clear fluid called cerebrospinal fluid, a slow, quiet river that cushions your brain, buoys it gently, carries away waste, and delivers nutrients in a continuous, calm circulation. This fluid means your brain actually floats, not heavily, not dramatically, but suspended gently in its own small sea. Your brain is, in a way, always adrift, always slightly buoyant, always held. Perhaps that's why thinking sometimes feels like floating. The blood vessels in your brain form an intricate branching network so dense that almost no neuron is farther than a fraction of a millimeter from a blood vessel. The brain cannot store energy the way muscles can. It needs a continuous delivery, glucose and oxygen arriving constantly, like a river that can never be allowed to run dry. 20% of your heart's entire output goes to your brain. Your heart, even now, is sending a fifth of every beat directly upward to keep this quiet universe illuminated. There are cells in your brain called glial cells. The name comes from the Greek word for glue. They were thought for a long time to be merely support cells, the quiet workers holding everything together while neurons got all the attention. But scientists have discovered that glial cells do far more than support. They help neurons communicate, they protect the brain, they guide its development from the very beginning. There are roughly as many glial cells in your brain as there are neurons, a whole second population working gently and largely without recognition. The brain also has its own immune system, specialized cells called microglia, small and watchful, that move slowly through the brain's tissue, cleaning up debris, monitoring for anything that needs attention, keeping the environment quiet and orderly. They are the brain's gardeners, pruning, maintaining, tending the vast interior landscape with patient care. And while you sleep tonight, they will work even more actively. Sleep is when the brain does much of its deepest cleaning and maintenance, when the spaces between cells actually expand slightly, allowing waste products to be flushed away more efficiently. Scientists call this the glymphatic system, and it is most active during deep sleep. Every night, while you dream, your brain is gently washing itself clean, preparing for another day. You can feel good about going to sleep. You're giving your brain exactly what it needs most. If this story is helping you settle in tonight, you're so welcome to like the video. It's such a small thing, but it truly helps the channel reach other people who might need a quiet place to land. And if you haven't yet explored the full playlist, there are many more stories just like this one, about forests and oceans and the night sky, whenever you're ready for them. For now, breathe. Feel the weight of your body, the warmth where you're resting. The brain that holds all of you is being held in return by bone and fluid and the soft dark of the night. We'll continue drifting gently into what comes next. There is something that happens in the brain every single night, so familiar that we rarely pause to wonder at it. Sleep. You've done it thousands of times, and yet it remains one of the most interesting and, in some ways, most mysterious things your brain does. Not an absence of function, not the brain simply switching off like a light, but a different kind of presence. a different mode of being alive. Sleep moves through stages, cycling through the night, like slow tides coming in and going out. In the lightest stages, you're still half aware. The room still vaguely present around you, sound still reaching you softly. Then the tide pulls you deeper into slow wave sleep, where your brain produces those long, rolling delta waves, and your body releases growth hormones, and your cells do their quiet repairs. And then, roughly every 90 minutes, you surface briefly into a different kind of depth. REM sleep, rapid eye movement sleep, the stage where most dreaming happens. During REM sleep, your brain is extraordinarily active, almost as active as when you're awake. Your eyes move beneath closed lids, quickly and in various directions, as if watching something. Your body, meanwhile, is temporarily paralyzed, a gentle safety mechanism that prevents you from physically acting out your dreams. You are both deeply still and internally vivid, both absent from the waking world and fully present somewhere else. Dreams are one of the brain's great mysteries. Everyone has them. Even people who say they never dream simply don't remember them. Most people have 4 to 6 distinct dreams per night, lasting anywhere from a few minutes to close to half an hour. By the time you've lived 70 years, you'll have spent roughly 6 full years dreaming. 6 years in that quiet other world. What are dreams for? Scientists have many ideas, all of them interesting, none of them complete. Dreams may help the brain process emotional experiences, replaying and reordering them in combinations that help you make sense of things. They may help consolidate memories, weaving new information into older structures. They may simply be the brain freed from the demands of the waking world, playing, wandering through its own archive the way you might wander through a beautiful, slightly strange museum after closing time, when all the lights are low and you can look at anything you want. The brain changes throughout your life in ways that are gradual, continuous, and full of quiet wonder. At birth, a baby's brain is only about 1/4 of the size it will eventually reach, and yet it already contains virtually all the neurons it will ever have. The growth that follows isn't primarily a growth in neurons, but in connections, in the branching, reaching, linking between neurons that gradually builds the landscape of a mind. A baby's brain is almost extravagantly open to learning. In the first years of life, it produces synaptic connections at an extraordinary rate, far more than it will eventually keep. Then, gradually, a process called synaptic pruning begins, and the connections that are used regularly are strengthened, while those that aren't used fade gently away, like a garden being slowly tended, not to make it smaller, but to make it more beautiful, more itself. This pruning continues well into adolescence and early adulthood, shaping and refining the brain's architecture in response to everything the person experiences, which means the brain you have right now is, in part, a record of your life. It has been shaped by every book you've read, every walk you've taken, every conversation that changed something in you. You and your brain have been building each other slowly, all along. The brain's ability to change in response to experience is called neuroplasticity, and it continues throughout life, even into old age, even now, even tonight. Learning something new, practicing a skill, paying close attention to something, even having certain kinds of thoughts. All of these can physically alter the brain structure, strengthening certain pathways, encouraging new connections, reshaping the landscape in ways subtle but real. Your brain is not fixed. It is not finished. It is always, quietly, in the process of becoming. There is a part of the brain called the insula, tucked away in the folds of the cortex, that is involved in body awareness, in the sense of what is happening inside your own body right now. The slight rise and fall of your chest, the warmth of the surface beneath you, the comfortable weight of your own limbs. The insula is translating all of that into felt experience, continuously, quietly, letting you know that you're here, that you're real, that your body is a specific and present thing in the world. When you check in with your body during meditation or relaxation, it is the insula you are engaging. When you notice with pleasure that you are comfortable, that is insula awareness. It is a deeply calming kind of attention, the brain noticing itself, like still water, noticing the sky it reflects. Your brain has a natural reward system, a pathway that runs through several deep structures, delivering that warm sense of rightness and goodness when you do something that serves you well. This pathway was originally designed for basic survival, food, shelter, social connection. But it responds equally to simpler things, to kindness received, to beauty noticed, to a story heard in the quiet before sleep. Something in this reward pathway is perhaps activating right now, the brain registering. This is good. This is safe. This is exactly what we needed. The sense of smell has a uniquely direct connection to the brain. While all other senses first pass through the thalamus, that quiet relay station, smell travels differently. Olfactory signals reach the limbic system almost directly, bypassing the usual routing, which is why a particular scent can unlock a memory instantly and completely, with a vividness that surprises you. The smell of a specific flower, a particular food, a type of wood or rain, and suddenly you are somewhere else entirely without warning. In this way, scent is the most direct line to your past that your brain possesses, a kind of time travel available at almost any moment, encoded in the soft architecture of memory and feeling, waiting quietly for the right trigger to bring it home. Language lives primarily in two regions of the brain, both named for the scientists who first described them in the 19th century. Broca's area, near the front of the left hemisphere, which is involved in producing speech, and Wernicke's area further back, involved in understanding it. When you speak, these two regions collaborate across the arc of a second. Wernicke's area finding the meaning, Broca's area shaping it into sound. And yet, language in the brain is far more distributed than just those two regions. Poetry activates different areas than instructions. A word heard with music behind it lights up different patterns than the same word spoken in silence. The brain's engagement with language is rich, wide, and wonderfully individual. Every person's internal language landscape subtly different, shaped by every story they've ever heard, every word that ever moved them. Words, then, are not just sounds. They are events in the brain. This story, these particular words in this particular order, are creating specific patterns of activation in your neural landscape right now, lighting certain paths, quieting others, being woven gently into you. Isn't that a beautiful thing to rest with? Your brain holds memories in different ways, depending on what kind of memory they are. There are memories of events, autobiographical, narrative memories, the ones you can tell as stories. There are memories of how to do things, riding a bicycle, writing your name, so deeply encoded that they live in the body as much as the mind. There are memories of facts, memories of feelings, memories of places so vivid that revisiting them in imagination can slow your heart rate and ease your breathing, the way returning to a beloved landscape might. The brain does not store memories like files in a cabinet, complete and identical each time you retrieve them. Instead, each time you remember something, you reconstruct it, assemble it from various stored pieces, allow it to exist briefly in full form, and then store it again. And each time it is stored, it is very slightly altered by the present moment, by your mood, by what you've just been thinking about, by the context in which you remembered it. Memories are not recordings. They are living things. They breathe and shift slowly over years. How extraordinary to know that the things you love, the memories you return to, are also being gently tended by your brain each time you revisit them. That remembering is not just retrieval, but recreation. That the warmth you bring to a beloved memory actually becomes part of it. Before we drift a little further, if you're listening from your bed tonight, and this is your first time here, welcome. This channel is for exactly this: quiet evenings, interesting ideas, and the feeling of being gently accompanied into sleep. There are many other stories in the playlist whenever you're ready for them. And if you'd like to leave a small comment, even just to say you were here, please do. It truly means something. Let your breathing continue to slow. Let the thinking soften. You don't need to hold on to any of this. Your brain will keep what it needs. One of the quietest things about the brain is also one of the most remarkable. It is always predicting. Not anxiously, not urgently, but constantly, seamlessly, in a way you never notice because it happens before awareness. Your brain is, at every moment, generating a model of what is most likely to happen next, and then checking that model against what actually happens. When your predictions are correct, when the world matches what your brain expected, very little conscious registration occurs. The sound of a familiar voice in a familiar place, the weight of a door handle you've touched 1,000 times, these match the model, and so they slip past awareness unnoticed. It is only when something doesn't match, when the world surprises the brain, that full attention is called up. This means, in a way, that we spend most of our lives inside a model, a smooth, continuously updated, deeply personal simulation of the world, constructed from memory and expectation, which we experience as direct perception. The brain fills in enormous amounts of information that it does not actually receive from the senses, completing patterns, smoothing gaps, presenting us with a coherent, continuous experience of reality that is partly constructed and partly received. And this is not a flaw. It is extraordinary efficiency. The brain receives vast amounts of sensory data every moment, far more than could ever be consciously processed. So it builds a model. It learns what to expect. And it frees conscious attention for what is genuinely new, genuinely surprising, genuinely interesting. The brain's visual system is one of the most elaborate and resource-intensive parts of the entire organ. About a third of your cortex is devoted in some way to processing visual information. And yet, the image that reaches your brain from your eyes is incomplete. There is a blind spot in each eye where the optic nerve attaches to the retina, and the vision it produces is sharpest only in a small central region, blurring toward the edges. Your brain fills in the blind spots. It constructs peripheral vision partly from inference. It presents you with a seamless, wide, colorful world. And much of that seamlessness is it completing the picture based on what it knows should be there, which means you have never in your life seen the world directly. You have seen your brain's best interpretation of the world, and that interpretation has been, almost always, beautiful and sufficient and true enough to navigate by. There is a region in the brain called the fusiform face area, a specialized cluster of neurons in the temporal lobe that respond specifically to faces. Faces activate this area so reliably and strongly that the brain will sometimes find faces where none exist, in the grain of wood, in a cloud formation, in the arrangement of shadows on a wall. You've experienced this, seeing a face in something that isn't one, the recognition arriving before the rational correction. This is the brain's face recognition system, so exquisitely tuned for human connection that it operates even when there is no human there. It is, in some ways, a measure of how important faces are to us, how wired we are for each other, how the brain never quite stops looking for a face, for the possibility of another person, of connection and recognition and being known. Your brain processes music in a remarkably distributed way, activating regions involved in hearing, movement, emotion, memory, and language all at once. Music, more than almost any other stimulus, seems to engage the whole brain, to light it up from one end to the other in shifting, responsive patterns. A melody can do in seconds what a novel might take hours to achieve. Slow, gentle music, like the kind that might accompany a story like this one, tends to synchronize with your brain waves. When the tempo of music hovers near 60 beats per minute, close to a resting heart rate, the brain can begin to align with it, slowing its own rhythms toward that pace. The music becomes a kind of external metronome for your internal world, and your body, following the lead of your brain, follows the music. You are, right now, being gently conducted. The brain is remarkable in its redundancy, its capacity to compensate when something changes. If one region is damaged, neighboring regions can sometimes take on its function, expanding their own role, rerouting pathways, finding alternative routes to the same destination. This is neuroplasticity in its most dramatic form. The brain reorganizing itself, like a river that finds a new course when an old one is blocked. The adaptation is rarely perfect, but it is often astonishing, a testament to the brain's deep commitment to continuing. People who are born blind from birth often show heightened activity in their visual cortex, that enormous region normally dedicated to sight, when they read Braille with their fingertips, or when they listen to music. The visual cortex, finding itself without the input it was originally organized around, takes on new functions, serving the person in ways no one designed. The brain turns empty land into garden. Your sense of time is constructed by the brain. There is no single dedicated clock region, but rather a distributed process, with different brain areas contributing to the sense of duration, sequence, and pace. Time, as you experience it, is an interpretation. And this is why time can move so differently depending on your state. An hour of boredom stretches, an hour of joy contracts. A moment of real presence, attending fully to exactly what is happening, can feel simultaneously very brief and very large, as if it contains more than its measured duration should allow. As you settle deeper into rest right now, your sense of time may already be shifting, minutes stretching, then blurring, then losing their edges. This is normal. This is the brain moving into its nighttime mode, where the careful, sequential marking of time matters less and less, and the soft, immeasurable quality of rest matters more. The brain contains a structure called the locus coeruleus, a tiny cluster of neurons in the brainstem, no larger than a few millimeters, and yet one of the most far-reaching modulators in the entire brain. From this small place, neural fibers reach outward to almost every region of the brain, releasing a neurotransmitter called norepinephrine, the molecule of alertness, of focused attention, of readiness. During waking hours, the locus coeruleus is active and busy, keeping you tuned and responsive. But as sleep approaches, it quiets. Its activity decreases slowly, like a lamp being turned down on a dimmer switch. And as it dims, the alertness it was maintaining softens too. You become less reactive to sounds, less interested in what might be happening elsewhere, more present to the single sensation of comfort and warmth where you are. Your locus coeruleus is dimming right now, gently, exactly as it should. There is a small pine cone-shaped gland deep in the center of the brain called the pineal gland. For centuries, philosophers wondered about it. René Descartes believed it was the seat of the soul. We know now that it produces a hormone called melatonin, released in response to darkness, signaling to the body that it is night, that sleep is appropriate, that the body can begin its long, slow preparation for rest. Right now, if it is dark where you are or dim, your pineal gland is releasing melatonin into your bloodstream. It has been rising for the past hour or two, a gradual chemical tide, and its message is simple and ancient and kind. The day is over. You have done enough. It is time to be still. Your ancestors responded to this message by the light of small fires, and then by candles. And now here you are, in your particular present moment, receiving the same chemical message that human bodies have received for as long as there have been humans. A continuity so long it becomes difficult to feel its edges. You are part of something that has been happening for a very, very long time. And it is good, and it is quiet, and it is yours. Please feel warmly welcome to share this story with anyone you know who has trouble sleeping or who simply loves gentle, curious things. And if you've been listening for a while and haven't yet liked the video, well, there's a small button right there, and it takes less than a second, and it genuinely helps. Thank you for being here. Truly. Let the melatonin do its quiet work. Let your eyes feel heavier. We'll continue drifting. There is something that scientists call the default mode network, and we mentioned it briefly before, but it deserves a longer visit in this soft hour, because the default mode network is where, in a sense, you live when you are not busy being anywhere else. When you stop focusing on a task, when your attention releases its grip and wanders freely, a set of brain regions activates together: the medial prefrontal cortex, the posterior cingulate cortex, the angular gyrus, and a few others. These regions form a network that seems to be associated with a self-referential thought, with thinking about yourself, about others, about the past and the future, about what things mean and how they connect. The default mode network is where you daydream, where you remember who you are, where you rehearse upcoming conversations and replay past ones, where you wonder about other people, what they're thinking, how they feel, what their lives are like. It is the network of narrative and imagination and empathy. It is, in a very real sense, the network of your inner life. And here is the interesting thing. It is most active when you are resting, which means that what feels like doing nothing is, neurologically, something quite rich. The mind wandering is the mind at a particular kind of work, the work of integration, of meaning-making, of becoming more coherently yourself. When you lie quietly before sleep, not focused on anything particular, letting thoughts arise and pass without holding them, you are letting the default mode network do some of its most important work. You are giving yourself over to a kind of slow, internal housekeeping, the brain reviewing and organizing the day, stitching together narrative, making quiet sense of things. This is not a luxury. It is, in its way, essential. The brain is surrounded by a blood-brain barrier, an extraordinary protective membrane that lines the blood vessels entering the brain and acts as a remarkably selective filter. It allows glucose and oxygen and other essential molecules to pass through freely. But It keeps out a large number of other substances, including many toxins, bacteria, and viruses that circulate in the bloodstream. The blood-brain barrier is like a very patient, very careful doorkeeper. It stands at every entrance to the brain and makes a continuous series of decisions about what may enter. Most things are turned gently away. Only what is truly needed gets through. This barrier is why the brain is so well protected from many infections. And it is also why, paradoxically, treating brain conditions is sometimes medically challenging. The same doorkeeper that keeps toxins out also keeps many medicines out. Scientists work in remarkable ways to find molecules small and compliant enough to slip through, to reach the brain on behalf of the person who needs them. The brain has no pain receptors, no nociceptors in the brain tissue itself. The brain that processes pain signals from every part of your body cannot itself feel pain. This is why brain surgeries can sometimes be performed with the patient awake, because once the surrounding layers are numbed, the brain itself feels nothing of what is done to it. It processes, but it does not feel in the same direct way. This means the brain holds no pain of its own. It receives pain from everywhere else, manages it, interprets it, gives you information about it. But inside its own soft tissue, there is only quiet. Inside the brain, there is quiet, the cerebellum, that small, wrinkled little brain, tucked at the base, contains more than half of all the neurons in your entire brain, despite being only about 10% of its total weight. It is extraordinarily dense with neural tissue, packed with cells in a way that allows for fine-grained, rapid coordination. Its involvement in movement and balance is its most well-known function, but research suggests it may be involved in more cognitive and emotional processes than once thought, that it participates in learning, in timing, in the smooth flow of thought, as well as physical movement. The cerebellum is very ancient, evolutionarily speaking. Versions of it exist in fish, in birds, in all vertebrates. It has been doing its quiet, essential work for hundreds of millions of years, managing movement and balance across an extraordinary diversity of bodies. In you, it continues that long work, overseeing the tilt of your head as it settles into your pillow, the minute adjustments of your breathing muscles, the slight shift of posture that makes you more comfortable without you ever deciding to make it. The brain has a kind of atlas inside it, a map of the body drawn across the cortex, where different regions of the brain correspond to different parts of your physical self. This map is called the homunculus, a Latin word that means little person. If you were to draw the body in proportion to how much brain space each part receives, you would get a strange and fascinating figure. Enormous hands and lips and tongue, a small torso, a face that is wide and sensitive. The hands and the mouth receive so much neural real estate because they are so extraordinarily capable of fine sensation and movement. Your fingertips right now are receiving extraordinarily detailed sensory information. the texture of wherever they're resting, the temperature, the very slight pressure of their own weight. All of that information is arriving in a wide swath of your cortex, being received and interpreted in continuous, quiet detail. Your hands know where they are. Your brain knows exactly where your hands are and is listening to them carefully, even as you drift. Mirror neurons are a remarkable class of brain cells that activate both when you perform an action and when you observe someone else performing the same action. When you watch someone reach for something, neurons fire in your brain that are associated with the act of reaching. When you watch someone wince, something like wincing occurs in your own neural activity. When you listen to a story about someone experiencing peace and rest, the brain regions associated with peace and rest participate, which means that a story about resting is, in a neurological sense, a kind of rest. You are resting right now in more ways than one. Mirror neurons may be part of why humans are so profoundly social, why other people's experiences feel so immediate and real to us, why empathy is not merely a learned skill, but a built-in capacity. We are wired to feel each other to some extent, wired to resonate. The brain that evolved in the context of community carries community inside it, always. There are roughly 100,000 miles of blood vessels in the human brain, enough to stretch from the earth to the moon, and then some. A distance so vast it seems impossible in something you hold in your hands. But the brain is extraordinarily intricate at very small scales. Its capillaries are tiny, winding, impossibly fine, reaching into every fold and layer, ensuring that every one of those 86 billion neurons is nourished. 100,000 miles of tiny rivers moving quietly inside you, all of them flowing right now in the dark, in the warmth, as you drift. The brain generates enough electricity during waking hours to power a small LED light bulb, about 20 to 25 watts. Not much in the grand scheme of electricity. A small, warm light, but constant and continuous, and yours. If you could see the electrical activity in your brain right now, if you could watch it the way you might watch a city from a great height at night, you would see it slowing. The busy, rapid flickering of full attention giving way to longer, slower pulses. Islands of quiet growing wider. The city moving toward sleep, lights dimming gradually, the bright center of waking activity narrowing and softening, the outer regions already dark and still. A city going to sleep is one of the most peaceful things imaginable. All that activity, quieting, all those small lights, one by one. If this story has become part of your nightly routine, thank you. That means so much. And if you're new and finding your way around the channel, the playlist is a good place to explore at your own pace. There are forests in there and oceans and the wide open night sky. Wherever you'd like to go, there's a story ready to take you. For now, stay here, stay soft. Let your brain continue its slow, beautiful dimming. Your brain has been with you from the very beginning, from before you were born, in fact. It began developing just a few weeks after conception, when a tiny strip of cells folded into a tube and began the long, intricate work of becoming a nervous system. That neural tube, delicate, translucent, barely visible, is the origin of everything. Your brain began as a fold, a gesture of becoming. By the time a baby is born, the brain has undergone an extraordinary amount of construction. The basic architecture is in place, the major regions established, the billions of neurons already formed and beginning to connect. And yet it is still, in many ways, unfinished. The most unfinished brain of any newborn in the animal kingdom. A human infant is born more helpless than almost any other young animal, because the human brain is so large relative to the birth canal that if it were more developed, birth would be impossible. So we arrive in the world open, requiring everything, dependent on the warmth and consistency of others in a way no other young animal quite is. And perhaps this dependency is part of why we are as we are, why human beings are the most elaborately social creatures who have ever existed, why connection and belonging feel not like preferences, but like needs, as fundamental as breathing. We needed each other from the first moment. The brain learned that fact at the deepest level and never quite unlearned it. A newborn brain grows at an astonishing rate, roughly doubling in volume in the first year of life. By age 2, it has reached about 80% of its adult size. This growth is fueled by the rich sensory environment the baby inhabits. Every sound and face and texture and warm weight, a piece of data the brain uses to build its model of the world. Babies are not passive recipients of experience. They are the most active learners who will ever exist, running experiments, testing expectations, revising models, all with the absolute urgency of creatures for whom understanding the world is a matter of survival. The infant brain is laying down the foundations of everything that will follow. The first emotional templates, the first experiences of being held and responded to, the first sense of whether the world is fundamentally safe and available or not. These early experiences settle deep into structures and patterns that persist in subtle ways throughout a life. Becoming part of the water everything else swims in, which is another way of saying how you were held very early is somehow still present in you, in the warmth or guardedness with which you approach the world, in what feels like home. Your brain, as you move through life, gradually shifts in its patterns of activity and rest. In youth, the brain tends toward exploration, novelty-seeking, risk-tolerant, energized by what is new. The prefrontal cortex, still developing, doesn't yet exert its full moderating influence. This is not a deficiency. It is a developmental feature, a built-in tendency toward expansion and discovery during the years when the world most needs to be explored. As the brain matures, it becomes more efficient, more selective, less interested in everything equally, more capable of the kind of sustained, deep attention that comes with knowing what matters. The experienced brain does more with less. It has pruned its connections to the ones that carry the most meaning and usefulness, And within those remaining pathways, the signals travel faster and more reliably. Aging brains remain capable of growth, connection, and genuine learning. The idea that the adult brain is fixed and finished is simply not true. Every experience you have continues to leave a trace. Every new thing learned creates new possibilities. The brain that you have at any age is not the brain you are stuck with. It is the brain you are still making. Your memory has multiple distinct systems, and they operate in different ways. The hippocampus, as we discussed, is essential for forming new explicit memories, the kind you can describe and narrate. But procedural memory, memory for how to do things, relies on different structures, including the basal ganglia and the cerebellum. Emotional memory is deeply influenced by the amygdala. Priming, the subtle way past experiences affect current perception, operates in distributed ways across many regions. These systems work together so seamlessly that from the inside, memory feels like one thing, like a single faculty, sometimes reliable and sometimes elusive. But underneath, it is a collaboration, many systems contributing to a single felt experience. This is true of almost everything the brain does. What feels like a single perception, a single emotion, a single decision is almost always the integrated output of many separate processes running in parallel, brought together into coherent experience without you ever having to supervise the synthesis. The brain does the background work. You receive the result. Every time you remember something, as we touched on before, you are reconstructing it, gathering its pieces from distributed storage, briefly reassembling them, experiencing them, and then storing them again. And each reassembly is slightly influenced by everything that has happened since, by your current mood, current understanding, current emotional state. This means that the memories you return to most often are the ones most shaped by who you are now. Your past is real, and it matters, but it is also being constantly read through the present. The person remembering is always here, now, coloring what is remembered. What memories will your brain tend tonight, in the dark? What will it quietly carry forward? What will it let soften at the edges, gentle and unheld? The brain has a region called the anterior cingulate cortex, a long strip that runs along the inner surface of the frontal lobe, like a gentle curve of coastline. It is involved in error detection, conflict monitoring, and the regulation of attention. When two impulses pull in different directions, the anterior cingulate is often where that tension is registered and mediated. But the anterior cingulate is also deeply involved in the social experience of pain, in the hurt that comes from feeling excluded or rejected or unseen. The same regions that respond to physical pain respond to social pain, and with remarkable overlap. Being ignored genuinely hurts, in a neurological sense that is not merely metaphorical. The brain does not sharply distinguish between a cut on the finger and a moment of social exclusion. Both arrive as pain signals. Both activate similar structures, which means, by the same logic, that inclusion genuinely soothes. being seen, even by a voice in the dark, even by a story that seems to know you're there, is received by the brain not only as pleasant, but as something like comfort, something like relief. The anterior cingulate registering. Someone knows I'm here. Something sees me. We see you here. We're glad you came. The brain modulates pain through its own internal systems, producing endorphins, the brain's own opioid-like molecules, in response to exercise, laughter, music, and connection. Endorphins were named from endogenous morphine, morphine that arises from within. The brain has its own capacity to ease suffering, its own quiet pharmacy, producing comfort when it is needed. And these same molecules are present in moments of warmth and safety and pleasure, in this specific felt goodness of being comfortable and at ease, which is what your body is right now, moving toward. This comfort has chemistry. This ease is real. Your brain is actively producing the molecules of well-being, and they are real as any mineral dissolved in mountain water drifting through you, carrying their message of ease. The brain is not just what happens in the skull. Your gut contains roughly 500 million neurons, a vast network sometimes called the enteric nervous system, or, more evocatively, the second brain. This gut brain communicates extensively with the brain in the skull via the vagus nerve, one of the longest nerves in the body, wandering from the brainstem all the way down through the chest and into the abdomen, carrying signals in both directions. The vagus nerve's activity is associated with calm, with social engagement, with the parasympathetic state, the body's rest and digest mode, as opposed to the fight or flight activation of stress. When the vagus nerve is well toned, as it is in people who regularly experience calm and safety and social warmth, the body moves more easily between activation and rest, more readily settles, more efficiently returns to ease after difficulty. Your vagus nerve right now, as your breathing slows and your body grows heavy, is activating its calming signals. The gut and the brain in conversation, both agreeing we are safe, we are warm, we can rest. Thank you for drifting with us tonight. If you'd like to share a quiet word in the comments, something you noticed, something that resonated, or simply a note that you were here, please do. This channel is a small, quiet gathering, and every person who shows up makes it more real. Keep breathing, keep softening. There is more to discover, and all of it is as gentle as this. Let's rest for a moment in the idea of attention, in what it means for the brain to pay attention to something, and how extraordinary it is that it happens at all. Your senses deliver a staggering amount of information to your brain every second. Millions of bits of data from your eyes alone, plus input from your ears, your skin, your proprioceptive system telling you where your limbs are in space, your vestibular system tracking your balance and orientation, your interoceptive system reporting on the state of your internal organs. All of this arriving simultaneously, continuously, from every direction. And yet, your conscious experience at any given moment contains only a very small portion of all that information. Attention is the brain's way of selecting, of choosing what to bring into full awareness and what to leave in the background. It is an extraordinary act of prioritization, happening automatically and continuously, largely outside your control, but responsive to your intentions. When you choose right now to attend to the sound of these words, or the sensation of your own breathing, or the warmth around you, you are directing the beam of attention, and the brain responds by amplifying the processing of that input, allocating more resources to it, making it more vivid and present. Whatever you attend to becomes, in a sense, more real, more fully processed, more deeply received. Attention shapes experience. The world you live in is, in part, the world you look at. There are two broad modes of attention that researchers often discuss. One is focused, directed attention, the beam turned deliberately toward something, held there with effort. The other is more open, receptive attention, a wide-angle mode, taking in whatever arises without fixing on any single thing, the soft gaze versus the sharp gaze. Sleep and the approach to sleep is characterized by the loosening of focused attention. The beam softens, widens. Things that were sharp become gentle. Thoughts arise and are not held. The wide, open, receptive quality grows, and with it comes a kind of spaciousness, a sense that awareness is large, and what moves through it is small and passing. This spaciousness is a gift. It is where rest lives. The human brain is the most interconnected object known to exist in the observable universe. Each cubic millimeter of cortical tissue contains roughly 4 kilometers of axons, the long, slender projections through which neurons send their signals. 4 kilometers in a cube smaller than a grain of rice. Multiply that through the entire brain, and the distances become incomprehensible. Hundreds of thousands of kilometers of neural wire, coiled and woven into a 3-pound organ. All of that connectivity is devoted to keeping you continuous, to making sure that what you felt yesterday is related to what you feel today, that your memories connect to your perceptions to your emotions to your actions to your sense of yourself. The brain's fundamental purpose, across all its complexity, is continuity, is the maintenance of you as a coherent, persisting thing across time. What a project. What a quiet, continuous, extraordinary project. The brain is the most metabolically active tissue in your body, consuming 20% of your oxygen and 20% of your calories, as we've mentioned. But during deep sleep, the brain's overall metabolism actually decreases substantially. The brain rests in its way. Its energy consumption drops. And yet, the cleaning processes we've discussed, the lymphatic flushing, the memory consolidation, continue, require different energy dynamics, work in the space created by that metabolic quieting. This is why sleep deprivation has such rapid and pronounced effects on cognition and mood. The brain, denied its nightly housekeeping, accumulates metabolic byproducts and unprocessed experience. The connections that normally support clear thinking grow sluggish. Emotional regulation becomes more effortful. The prefrontal cortex, which helps moderate emotional reactions, is among the first systems to show the effects of insufficient sleep. A rested brain is a different brain, more patient, more creative, more capable of seeing connections, of letting go of rigid patterns, of approaching problems with a freshness that the tired brain cannot access. Sleeping is not a passive withdrawal from life. It is active care for the brain. It is maintenance and restoration and preparation. Every hour of good sleep is a gift to tomorrow's clarity. Your brain, as a biological organ, has been shaped by evolutionary pressures spanning hundreds of millions of years. But the particular human brain, with its enormous frontal lobes, its rich language systems, its extraordinary capacity for abstraction and imagination and culture, represents something that emerged relatively recently in geological terms. Over the past few million years, the human brain tripled in size. No one knows entirely why, but language, social complexity, the use of tools, and the demands of living in large groups likely all played roles. What this means is that your brain is a collaboration between ancient and recent. The brain stem and the limbic system are ancient. They are continuous with the brains of fish and lizards, conserved across hundreds of millions of years because they work. The prefrontal cortex, the language areas, the circuits for complex social cognition. These are newer. The ancient parts and the recent parts work together, and sometimes the collaboration is not entirely smooth, but it is always, in its way, human. You carry the deep past inside your skull. You carry the long story of life becoming more complex, more feeling, more knowing. And tonight, that long story is gently doing what all long stories eventually do, coming to rest. The brain of a sleeping person is not unresponsive to the outside world. Certain sounds will still register, especially sounds that carry personal significance. Your own name, spoken softly, will activate auditory processing even in sleep. A baby's cry will wake a parent much more reliably than the sound of traffic. The sleeping brain is not absent. It is simply behind a gentle veil, still listening, still somewhat present, while the deepest part of itself does its quiet night work. This means that voices heard in sleep, in the shallow stages in the drifting approach, are genuinely received, which is why stories before sleep are not wasted. Why lullabies work, not just for children, but for the adult brain that still, in its depths, recognizes the comfort of a voice in the dark. The voice continues. The brain continues to receive. And somewhere in that reception, the story becomes part of the night's soft content, woven into whatever the brain is doing in these borderland hours. Somewhere between waking and sleep, there is a state the brain passes through. Hypnagogia, it is sometimes called. A threshold state. A liminal zone. Here, the normal logical structure of thought begins to dissolve. Images arise without context. Fragments of language appear and don't connect to sentences. Sensations occur, falling, floating, sudden starts, that feel vivid without being dreamed. Hypnagogia is the brain crossing over, the transition visible from the inside. Many people have had important ideas or images arrive in this threshold state. It is sometimes described as a place of unusual creativity, where normal constraints are loosened and unexpected combinations become possible. Right now, if you are beginning to feel that soft dissolution, that loosening of the logical hold, that beginning of imagery without narrative, you are entering hypnagogia. You are crossing. The story does not need to follow you all the way. You can let it trail here at the threshold and carry only warmth across with you. Before we continue drifting, please feel free to look for the playlist if you're here for the first time. There are many more quiet hours of stories where this one came from. And leaving a comment or a like is a small act that does genuinely help this channel continue. Thank you for being here. Thank you for trusting this gentle space. Let the threshold take you gently. The rest of the story will be here if you return. If you're still with us, whether drifting in and out, or simply resting with the voice for company, that is exactly right. There is no wrong way to be here. Let's continue exploring softly the concept of consciousness, of there being something it is like to be you, of experience having this particular felt quality, is one of the great open questions of neuroscience and philosophy. Scientists and thinkers have approached it from many angles, and the honest answer, as of now, is that we do not yet fully understand how the physical activity of the brain gives rise to subjective experience, to the redness of red, to the exact felt quality of this moment of drowsiness. This gap between the measurable physical brain and the immeasurable felt quality of being alive is sometimes called the hard problem of consciousness. It is hard not because scientists are insufficiently clever, but because it may require entirely new ways of thinking about the relationship between matter and experience. And that unknowing is, in its way, comfortable. It means the person who lies here tonight, feeling the warmth of consciousness before sleep, is at the frontier of what is understood, is holding something that science has not yet quite reached. The felt quality of your drowsiness is, in this moment, something that no instrument has fully measured and no theory has completely explained. You are, in some deep sense, beyond the edge of the map. Creativity is one of the most distinctly human things the brain does, and one of the most mysterious. It requires the default mode network we discussed, which generates possibilities and connections. It also requires the executive control network, which evaluates and refines. And it requires something else, a kind of relaxation of habitual patterns, a loosening of the usual routes that allows the brain to find unexpected connections between things it normally keeps separate. This is why insights sometimes come in the shower, on walks, in the moments before sleep. These are states of relaxed, unfocused awareness, states where the default mode network can roam freely and the brain's habitual constraints are loosened. The creative insight was not absent before. It was simply waiting for the right conditions, waiting for quiet, waiting for the mind to let go of what it thought it was looking for. Perhaps something is waiting for you tonight. Some connection, some understanding, some small peace that will arrive in the dark because you were still enough to receive it. The sense of touch is processed by a region of the brain called the somatosensory cortex, a strip running across the top of the brain that contains that body map we mentioned, with its enormous hands and lips. Touch is one of the most ancient senses, evolutionarily speaking. The first sense to develop in human embryos, the one most directly wired to emotional and social circuitry. Touch and safety are deeply linked in the brain. Gentle, consistent touch in infancy is essential for healthy development. It activates systems that regulate stress, that build the foundation of trust, that establish the sense of being held by the world, the feeling of warmth against skin, the particular comfort of a blanket, or a warm surface, or a familiar weight, is processed not just as sensory information, but as emotional information, as message, as meaning, as comfort. The warmth you feel right now, wherever your body is resting, is being received by your somatosensory cortex and translated into felt comfort. Your brain is reading the temperature and the weight and the texture of what surrounds you, and producing from all of that the feeling of being held. You are being held. In a small and real and physical way, the world is holding you right now. The circadian rhythm, the brain's internal clock, runs on a cycle of roughly 24 hours, regulated by the suprachiasmatic nucleus, a tiny region of the hypothalamus containing about 20,000 neurons. These neurons contain their own internal clocks, individual cells that cycle through a chemical rhythm of about 24 hours, even in isolation. The brain's timekeeping is distributed all the way down to the cellular level. This clock was set evolutionarily by the light-dark cycle of Earth's rotation, by sunrise and sunset, by the length of days as they change through the seasons. It is ancient, this rhythm, older than human beings, older than mammals. The 24-hour internal clock is one of biology's most conserved features, present in organisms from bacteria to trees to you, all synchronized to the same great turning of the planet. When you feel sleepy at night, you are participating in something planetary, something shared across almost all of life on Earth, this common rhythm, this synchronized breathing in and out of wakefulness and rest that moves through the entire living world. Right now, somewhere in the dark, trees are in their own version of night mode. Their metabolic activity slowed, their stomata closed, their slow life quietly processing the days taken in light. Birds are roosted, each one with its head slightly tucked, its brain cycling through sleep stages not entirely different from your own. Insects are still. Even the soil is different at night. Different organisms active, different chemistry at work. The whole living world rests together, and you are part of that resting. You and the sleeping trees, and the still birds, and the soil breathing slowly in the dark. All of it, one enormous organism turning gently with the planet through the night. Your brain, in moments of genuine aesthetic experience, in the presence of beauty that moves you, shows activation across many regions: visual areas, emotional areas, reward pathways, regions involved in bodily sensation. Beauty is not a single thing happening in a single place. It is a whole brain event, an integrated response to something that the entire system recognizes as worth stopping for. And there are moments when the beauty is interior, when a thought or a realization has the quality of beauty, when an idea arranges itself into a form that feels right, not just logically, but aesthetically, when the pieces come together with a clarity that produces something almost like joy. These interior aesthetic moments activate many of the same regions as external beauty. The brain does not sharply distinguish between a beautiful landscape and a beautiful idea. You are capable of being moved by ideas the way you are moved by the sight of light on water. The brain makes no sharp distinction. Beauty is beauty. What ideas have moved you this evening? What small bits of the brain's quiet story have landed differently than you expected? There is no need to hold on to them now. They will keep or they will drift, and either is fine. We are nearly at the end of this long, soft exploration, but not quite yet. There is still more of the night to spend together, drifting gently through what is most extraordinary and most quiet about the universe inside you. Stay warm, stay easy. Let your breath do what it already knows how to do. Your brain is, among other things, a prediction machine, and one of its most remarkable predictions is the prediction of your own self. The sense of being a continuous, coherent I, persistent from yesterday to today, recognizable to yourself across years of change, is not something simply given. It is actively constructed, maintained, moment to moment, by the brain's continuous work of integrating memory, sensation, expectation, and narrative into the felt experience of being someone. This self that the brain constructs is genuinely continuous. It is the same someone who went to sleep last night and woke this morning, but it is also genuinely constructed. It is not fixed or solid in the way a stone is solid. It is more like a river, always moving, always in the same place, made of different water at every moment. There is a kind of freedom in this. The person you are tonight is real and coherent and fully yourself. And it is also true that the person you will be after years of experiences and learning is equally yourself, continuous and different at once. The way the river is both always the river and always changing. You are not stuck. You are flowing. The brain responds to narrative, to stories, in a way that is neurologically distinct from how it responds to simple information. When you receive information in list form, certain processing regions activate. When the same information is delivered as a story with character, sequence, causality, and felt experience, a wider network activates. Language regions, motor regions, sensory regions, emotional regions. The brain simulates the story. It participates in it. This is why stories affect you in ways that facts alone often don't. When you hear a story about someone walking through a forest, your motor cortex shows mild activity as if you yourself were walking. When you hear a story with warmth and safety in it, your brain's comfort-related circuits participate. A story well received is not merely heard. It is, in some measure, lived, which means that this story, this particular slow, warm, gentle story about the brain, is being lived by you even now. The warmth in it is actually warm to your neural systems. The rest it describes is being registered, in part, as rest. Stories are one of the oldest technologies humanity has. Before writing, before agriculture, stories were how knowledge was transmitted, how values were shared, how the young learned from the old, how communities maintained their sense of who they were. The brain evolved in an environment thick with stories. It is built for them. It is comfortable in them. You are in exactly the environment the brain loves best, right now. Warm, safe, hearing a story in the dark. Music, mathematics, poetry, and language all share something in the brain. They are all processed as patterns. The brain is a pattern recognition system of extraordinary sophistication. It sees patterns in sound, in light, in movement, in sequence, in the behavior of other people. It is always finding structure, always organizing the world into regularities it can predict and exceptions it must update for. This pattern finding is why music feels inevitable, why the resolution of a musical phrase feels not just pleasant, but right, expected, earned. The brain tracked the pattern, predicted the resolution, and was gratified by its accuracy. And it is why unexpected beauty, the sudden, surprising metaphor, the note that arrives from nowhere, can create a particular kind of delight. The pattern breaking open into something larger than it predicted. Your brain has found patterns in this story, comfortable regularities of rhythm and warmth, and also perhaps occasional moments where something landed differently than expected, where a fact or image arrived with a particular quality that made you pause, even slightly, even for a single breath. Those moments of gentle surprise are the brain updating its model, expanding its world by one small, beautiful increment. The brain has a small region called the retrosplenial cortex, involved in navigation, in spatial memory, in remembering environments. It's active when you think about familiar places, when you mentally navigate the layout of a space you know well, when you imagine your home, when you retrace a beloved walk in memory, corner by corner, detail by detail. This region may be active right now as you approach sleep, helping the brain locate itself in familiar space, confirming the spatial safety of where you are. Your room, or wherever you're resting, has a mental map in your brain. The brain knows spatially where it is. And familiar spaces carry their own particular comfort, a spatial knowing that contributes to the felt sense of safety, of home, of here. This is why sleeping in your own bed, in your own place, usually feels easier than sleeping elsewhere. The brain's map matches its expectation. The place is known. There are no spatial surprises to manage. You are in a known place. Your brain has this place mapped. Everything around you is familiar, predictable, held. The brain processes sound even during sleep, continuing to monitor the acoustic environment, allowing sounds that are familiar and expected to pass without raising alarm, while remaining sensitive to sounds that are novel or that carry particular significance. This acoustic monitoring is managed with a beautiful efficiency. The sleeping brain becomes very good at ignoring what it can afford to ignore. Familiar, quiet sounds, rain against a window, wind in trees, a steady voice, can actually deepen sleep rather than disturb it. They provide a constant, predictable acoustic texture that reassures the monitoring brain nothing has changed. All sounds are accounted for. There is nothing requiring attention. This is, in part, why people have used sound accompaniment for sleep across cultures and throughout history. Lullabies and chanting and wind and leaves and the sound of rivers, all of them providing that steady, predictable texture that tells the brain the world is continuous, the world is ordinary, you can rest. This voice is one of those sounds, continuous, familiar, carrying nothing sharp or sudden. The brain can account for it and set it aside as safe, which means it is free to drift deeper, following the sound, without needing to track it carefully. You can let these words become more like sound than meaning, if that helps. You can let them wash through like water moving over smooth stones. Still there, still constant, requiring nothing. The experience of gratitude has measurable effects on the brain, activating the medial prefrontal cortex, the anterior cingulate, the regions associated with social emotion and reward. Feeling genuinely thankful for something, even something small, produces a brief, real warmth in these circuits, and practiced gratitude, engaged in regularly over time, has been associated with changes in how these circuits function, a gradual reweighting of attention toward the positive and meaningful. Tonight, before the deepest sleep comes, your brain might find one small thing, one small warm thing from the day, or from this story, or from simply being alive and breathing and warm, to briefly feel grateful for. Nothing elaborate, just a small recognition, a quiet yes to something. And then you can let even that go. It has done its gentle work. Do drop a comment if you're finding your way to sleep through these stories, knowing that helps. And the like button and the playlist, they're all there for you whenever you want them. For now, this voice, this warmth, this quiet. As we move deeper into this quiet night, let's visit one of the brain's most fascinating abilities, the ability to heal. Not in the dramatic sense, but in the slow, daily sense, in the way the brain continuously maintains itself, adapts itself, adjusts its own chemistry and structure in response to what the person experiences and does and needs. Every time you learn something, the brain changes. Connections between neurons are strengthened by use, a process sometimes described with the phrase, neurons that fire together, wire together. The more often a particular neural pathway is activated, the more efficiently it conducts signals. The connection becomes, over time, a kind of groove, easier to fall into, quicker to travel, deeper and more reliable. This is how skills develop, how habits form, how thoughts that were once effortful become automatic. The brain is always optimizing for what is used most, always deepening the grooves that are traveled, always letting less used paths grow faint with disuse, which means that whatever you practice, you become better at, including rest, including the approach to sleep. Every time you find a quiet place, every time you allow your body to soften and your thoughts to slow, you are strengthening the neural pathways associated with that transition. You are making it, over time, a little easier, a little more familiar, a little more like something your brain knows how to do. You are practicing right now, practicing ease. The brain has a remarkable relationship with music, which we touched on before. But one particular aspect is worth dwelling on: musical memory. Of all the types of memory, musical memory appears to be among the most robust, persisting into advanced age, even when other types of memory become fragmented. Songs remembered from youth remain accessible when other memories have faded. The tunes of childhood play on in a brain that may no longer recognize faces it once knew well. Why music, of all things? Perhaps because music engages so many systems simultaneously: motor, emotional, auditory, language adjacent, memory adjacent, that it is encoded with unusual redundancy, stored across many systems rather than in a single one. When one path is blocked, others remain. Music, in some sense, is stored everywhere at once, like light that enters a room through many windows. If there is a song from your past that carries warmth, something from a time when things felt good, something associated with a specific place or person or season, your brain has stored that song in remarkable detail. The melody, the timbre, the emotional texture, the specific feelings that surrounded it, all of that is still there, exactly where it was left, waiting quietly for the right signal to bring it forward. You could hear it now if you wanted, in the interior silence of your own mind. Not the words necessarily, just the sound of it, the shape of it, the warmth it carried. Let it play softly if you'd like. No one needs to hear but you. The brain's relationship with the natural world is ancient and deep. Before there were cities or buildings or artificial light, the human brain evolved in direct, continuous contact with natural environments, with soil and trees and water and weather and the sounds of other animals and the rhythms of seasons. The brain was shaped by that contact, tuned to it, calibrated by it. Researchers have found that exposure to natural environments, forests, bodies of water, open skies, tends to restore attention, lower stress hormones, slow the heart rate, and improve mood. These are not merely pleasant associations. They are measurable physiological shifts, occurring reliably and sometimes rapidly in response to natural environments. Some scientists use the term biophilia, a love for life, for living things, to describe the deep affinity that humans seem to carry for the natural world. It is, in a sense, recognition. The brain encountering what it was built within and feeling, perhaps for the first time, in a day of screens and concrete, something like relief. The sound of water is particularly effective at producing calm. The brain categorizes it as a non-threatening, continuous sound and can relax its monitoring more completely in its presence. The sound of wind and leaves, similarly, of rain, of birdsong at a distance. These are the sounds in which human brains developed, the acoustic environment of the original world. When you feel particularly calm near water, in forests during rain, your brain is returning home, is recognizing something, is settling into a frequency it has always known. Somewhere right now, rain may be falling somewhere on Earth. Almost certainly, rain is falling somewhere. Water is meeting leaves in forests, creating that particular soft percussion, that continuous and gentle sound. And somewhere, a brain like yours is hearing it and softening in response. The calming frequency of rain on leaves has been repeated so many times in human evolutionary history that it has become a kind of signal, a promise. Everything is fine. Water is falling. The world continues. You can rest. The hippocampus, that seahorse-shaped memory region, is also deeply involved in spatial navigation. It contains neurons called place cells that fire specifically when you are in a particular location, serving as neural GPS coordinates, mapping your position in the world. When you enter a familiar room, specific place cells activate that haven't fired since your last visit. The room is recognized neurally before you consciously register it. These place cells were the clue that led to the discovery of the brain's mapping system, a grid-like network of cells in nearby regions that create a coordinate system, a framework of space within which place cells can situate you. This discovery earned its researchers the Nobel Prize in Physiology and Medicine in 2014. The brain does not merely visit spaces, it builds them internally with extraordinary geometric precision. You carry a map of everywhere you've ever spent significant time, every childhood home, every school, every place that mattered. All of those spaces still exist inside you, mapped in the neural tissue of your hippocampus. You could navigate them in darkness, in memory. You could find your way. The sense of smell, as we explored earlier, reaches the limbic system with unusual directness. And there is a particular kind of smell-triggered memory, sometimes called a Proustian memory, named for the writer Marcel Proust, who described how a single taste of a small cake dipped in tea unlocked a vast involuntary flood of detailed memory of a childhood summer. These moments of involuntary smell or taste-triggered memory are among the most vivid and complete experiences of memory the brain can produce. They arrive whole, not summoned, but triggered, not reconstructed, but apparently complete. The past returning as fully felt experience for a single, astonishing moment. If you've had such a moment, if a smell has ever transported you entirely, for a few seconds, back to somewhere you had almost forgotten, You know the extraordinary quality of it, how it is different from ordinary remembering, how it seems to come from somewhere deeper than decision. That is the limbic system receiving a direct message. That is the brain's oldest memory systems holding something close that the newer systems had set aside. We carry everything. Everything that ever mattered is still somewhere inside. As you drift, feel the warmth of that. Everything lost is also, in some form, carried. The brain forgets very little entirely. It only sets things further back in the quiet archives, where they wait patiently for the right signal, the right season, the right soft moment in the dark. The playlist holds many more of these soft moments whenever you want them. And a small like or comment on the video is always welcome. It helps so much. Thank you for coming tonight. There is a thing the brain does that is very simple and very mysterious. And we've been doing it together for a while now. The brain listens to language and converts it into experience. Takes sequences of sounds or shapes on a page and builds from them something felt. Images, sensations, emotions, ideas that carry temperature and texture and the quality of being real. You have been somewhere tonight that doesn't exist. You have been inside an idea, inside the soft geography of a concept, visiting places in neuroscience the way you might visit places in a landscape. And your brain has produced from all of it something that has had genuine physical effects on your body. Slower breathing, heavier limbs, the approach of sleep. Words became chemistry. Story became rest. That is what language does, and it is one of the most remarkable things about being human. Language in the brain is not confined to a single location, as we know, but the regions most associated with it sit largely in the left hemisphere. In that region, around Broca's and Wernicke's areas, the classic language cortex. And yet, language comprehension, in its full richness, draws on regions across the whole brain. Visual cortex for imagining the scenes described, motor cortex for simulating the movements mentioned, emotional centers for feeling the tones and textures of meaning, default mode network for connecting what is heard to the self. When you read a description of a rough texture, the somatosensory cortex shows mild activation. When you read about someone jumping, the motor cortex responds. Language does not only tell you about experience, it partially enacts it. It creates, in the brain, a partial version of the thing described. Every story, then, is a kind of simulation. Every description, a partial embodiment. Every sentence that carries warmth leaves a trace of warmth in the body that received it. The brain has a remarkable tolerance for ambiguity, a capacity to hold open questions without discomfort, at least when it feels safe. This capacity is associated with the prefrontal cortex's moderation of the amygdala, the reasoning center gently managing the alarm system, saying, "This uncertainty does not require immediate resolution. It is safe to not know, and there is a kind of pleasure in not knowing, in the open question, in the mystery held gently, the feeling of genuinely not knowing something, held without anxiety. can produce a quality of curiosity that is itself deeply enjoyable. The brain exploring open territory without urgency. The mind in motion, not toward a destination, but for the pleasure of moving. So much of the brain's life is spent in not knowing, and the brain is, most of the time, entirely fine with that. It finds its footing and continues. The concept of emotional regulation is one of the most important things the brain learns. The ability to experience strong feelings without being overwhelmed by them, to allow emotions to arise and move through without needing to act on them immediately or push them away. This regulation is partly managed by the prefrontal cortex, which can, when functioning well, send calming signals to the amygdala, a top-down modulation that says, "I see you. We don't need to act on this right now." The development of this regulation is one of the great projects of childhood and adolescence, one that continues in its refinements across a lifetime. With attention, with practice, with the accumulation of experiences that show the brain it can handle what arises, the capacity for regulation deepens. Equanimity becomes more available. The emotional weather is no less real, but the capacity to weather it is greater. Right now, in this quiet hour, there is very little emotional weather to manage. The night is still, the body is warm, the thoughts, whatever they are, have softened. The prefrontal cortex is sending its calm, steady message, and the amygdala is receiving it, and everything is quiet in the country of feeling. This is a state worth noticing, a state to recognize when it's present, so that over time the brain can find its way back to it more easily. Equanimity, recognized, becomes a known destination, a place you can find again. The brain is capable of producing states that feel profoundly peaceful, states that have been described by meditators across cultures and centuries as unusual in their quality, as deeper than ordinary rest, as accompanied by a sense of spaciousness and clarity, and something like joy without an object. These states can be accessed in different ways, through meditation, through contemplative practice, through certain conditions of rest and safety, and deliberate attention. Neuroscience has begun to study these states, and what it finds is that they are real, measurable in brain activity associated with specific patterns of neural coordination, reproducible and understandable. The sense of expanded space, the feeling of time slowing, the quality of peaceful aliveness, these have neural correlates. They are the brain doing something specific, and what it is doing appears to be healthy and restorative. You don't need to meditate to touch the edge of such states. Sometimes they arrive at the edge of sleep, in the gentle dissolution of hypnagogia, when the rigid architecture of ordinary thinking softens and something larger, briefly, becomes available. A sense of openness, of being contained in something much larger than the body, of thoughts arising in space rather than filling all of it. If you feel any version of that right now, even a small, ordinary version, you can rest in it. There is no need to name it or hold it carefully. It will be what it is, as long as it is. The brain, in these moments, may be touching something very fundamental about the nature of consciousness, some deeper register of awareness that underlies the ordinary traffic of thought and sensation. We don't understand this fully, but it is real, and it is yours, and it is available to you in quiet moments like this one. Rest in it gently. One more quiet observation before we drift a little further. Your brain, right now, is doing everything it has always done, regulating your body, maintaining your memories, generating your experience. And it will continue doing so through the night, through deep sleep and dreams, and the slow, rich processing that the dark provides. You don't need to supervise any of it. It knows what to do. The brain does not need your help to sleep. It needs only your permission, your willingness to release the day, to stop managing, to let the automatic systems do what they evolved to do so beautifully. So, you can give that permission now, if you haven't already, completely and without reservation. The brain will handle everything else. Only to rest, as the brain already knows how to rest, as the body has always known how to rest, as the whole living world is resting right now alongside you, in the quiet, in the dark, in the long, unhurried peace of the night. Sleep well.